Welcome to my channel. Today we are going to learn about the discovery of anode rays marked a turning point in the late 20th century. So let's start. Scientists were already familiar with the cathode rays, which are a stream of electrons emitted from the cathode in a discharge tube. During such experiments, what might be happening at the anode? To identify that, in 1886, German physicist Eugen Goldstein performed some experiments. He used a perforated cathode in the modified cathode ray tube. So this is the gas discharge tube made of glass. Here two metal plates are placed in it. One is anode and another one is perforated cathode. Perforated cathode means it had holes in it, and these two electrodes are connected to high voltage battery. A small amount of residual gas sprayed in between these two electrodes, and he applied high voltage. When he applied high voltage, the cathode rays began to traveling from cathode to anode. At the same time, the electrons emitted from the cathode collide with the residual gas molecules. So these collisions creates a positive charged ions which are accelerated towards the cathode, produce a beam of positively charged particles on the back of the cathode. As the positively charged ions or particles passes through the holes of the canals in the cathode, they are called canal rays. Also they call as anode rays because they are coming from the anode. Scientists had an idea that these rays are made of positively charged particles. Still, they have to verify that. They applied electric field backside of the cathode. What happened when they applied electric field backside of the cathode? They found that these rays were attracted towards the negatively charged electrodes. We already know that like charges repel each other and unlike charges attracted each other. The particles are attracted towards the negative electrodes, so they confirmed that these are the positively charged particles. Therefore, these are often called as positive rays. Now, they wanted to know the behavior of these anodes. So, they did some experiments. First, they placed a pedal wheel backside of the cathode. So, what happens when they place a pedal wheel backside of the cathode? As expected, the pedal wheel will start spinning. So, they found that these anode rays are made of particles which have mass and velocity. Next, they applied magnetic field. So what do you think will happen when you bring a magnet close to these positively charged rays? Well, you are right. These rays will bend upward because the direction in which rays will deflect depends on the nature of the charge. If you notice carefully, you will see that the deflection in case of anode rays is way less than compared to the cathode rays. But why is that? We already know that the effect of a perpendicular force on a moving particle in a straight line is always less in case of heavier object than compared to the lighter objects. So what does that tell us about anode rays? That tells us even though we are using the magnet of the same strength in both the cases, the deflection in the case of anode rays is less because anode rays must be made of particles which is heavier than the particles in the cathode rays. Now, to understand the nature of these charged particles, scientists changed the gases in the tube and checked if the deflection would change. But they found something interesting. They found that the deflection changed every time they changed the gases. They saw that deflection in the case of heavier gases was less and deflection in the case of lighter gases was more. So this clearly tests that the particles coming from the heavier gases had more mass and particles coming from the lighter gases had less mass. The difference between the cathode rays and anode rays, first one is cathode rays are traveling in straight line and anode rays also travel in straight line. Second one is they are deflected towards positive plate, so they carry negative charge. So this is cathode rays second point, and in anode rays they are deflected towards the negative charge plate, so they are carry positive charge. Third, The particles present in cathode rays are electrons. Particles present in the anode rays are positively charged particles. Electrons present in cathode rays have same charge and mass, but the charge on the particles depend on the number of electrons lost by atoms in anode rays. Last, they originate from cathode and these anode rays are originate from anode. So if you have any doubts about cathode rays, please watch my previous video, Discovery of Electrons. In my next video, we will learn discovery of radioactive and types of rays. Thanks for watching. Please like, comment and subscribe my channel.